All right, I have chosen 2 of the round bottoms from last lab, sort of at random. I'll be working the others up, but we're going to focus on these 2. So the first thing to do then is to start adding the 2 molar hydrochloric acid to break up the product and as well as oxidize the extra magnesium. So let me get that. So I'm just going to start a squirt into each of the 2 I picked. And continue in this fashion until the HCl doesn't bubble anymore as the magnesium forces the hydrogen out. Here again, I'm adding small portions of diethyl ether to keep the volume of the organic up, as well as then more and more HCl, and then swirling it until I get all that magnesium taken care of, as well as get the product to separate from the aqueous layer. So hopefully you can start to be able to see, now that a lot of the cream color is gone, how the HCl actually bubbles when it hits the magnesium. Here again, single replacement reactions, as magnesium forces the hydrogen out of the acid and as hydrogen gas. You can also start to see a second layer start to form as the aqueous layer builds up. Okay, the next step then is to separate the 2 layers, the organic and aqueous. And from this point on, we're going to treat the samples together. As for the others, I just wanted to get them to where I could separate out the organic and the aqueous, and then they will be disposed of. Alright, so there's our 2 layers. Aqueous is on the bottom, as diethyl ether has a much lower density. So we're going to drain that. Since I'm going to be re-extracting this with some fresh, I went ahead and let all the organic aqueous and just a touch of the organic into that beaker. This then is the combined organic layers. We're going to set that aside for just a moment. Aqueous back into the set funnel with some fresh diethyl ether. PDF calls for 5 mils, but since I'm doubling the volume, about 10 mils, maybe a little more. One of the stoppers I took out of the round bottoms. classic shake and bend. And you can see, hopefully, that the ether has turned a little bit darker. It's gone from absolutely clear to slightly yellow. Now, since this is my final separation, I want to be a little more careful as I come to the intersection between the aqueous and the organic phase. Combine the organic layers. Then I'm going to take them into the instrument room and put drying agent in them, cover it for about 5 minutes, and then we'll get started on the rest of it. Alright, so we've sat for a while. I decided not to parafilm it as it was only me. I could just let it sit in the hood. So right now I'm going to start decanting now. Because of the volume, I may not decant it all at once. And in fact, that's probably about as much as I want. But I'm going to put it on this hot plate that's set around 2. And every so often I'm going to come back. I'm going to give it a swirl. I'm going to keep an eye on it here again just to make sure that we don't just ignite it. But the whole idea is to drive off the diethyl ether until it gets to be nice and concentrated. And then I'm going to add the Lagroin or PET ether to crystallize the triphenylmethanol. A look at our diethyl ether evaporating. Alright, the ether is just about gone. Yeah, I can still feel a little bit of the liquid evaporating, but it's just about gone. So here I've measured the 10 mLs of PET ether or Lagroin that the PDF calls for. And I'm going to pipe it in a couple of mils. Okay. Not maybe about half of it. Let's see if I actually hit the... And here again, the product is not particularly soluble in hexane, which is most of what makes up Lagroin. Okay, so it should help crystallize it out. Turn the heat off, and you can start to see the solid product in the bottom of our flask there. So I'm going to leave it on the residual heat just another few minutes, make sure that all the diethyl ether is gone, and then I'm probably going to let it cool, then collect it via vacuum filtration. Okay, our triphenylmethanol has cooled, and I'm getting ready to collect it via vacuum filtration. I went ahead, cut my filter paper, got a mass on it. Now I'm going to wet the filter paper with a little bit of Lagroin, since that's our solvent, to make sure that it stays in place. Now, Lagroin is pretty volatile, so it's trying to separate out. Also, I took the rest of the 10 mLs of Lagroin that I didn't use when I was precipitating and went ahead and pre-chilled it while the rest of the diethyl ether came out. Here again, the product's not real soluble in the PET ether, but any little bit helps. So making it cold is less likely to dissolve my product. For this last little rinse, I'm going to go ahead and take the vacuum off before I pour the rest of the PET ether in there. See if I can convince the rest of that product to come out of the Erlenmeyer. Okay. And you'll notice that the Lagroin is actually helping to clean it as well. You know, I've got enough left in here, even though it's not particularly cold. I'm going to take another ml or two. see if I can't get this product to move over and to clean that product that's already in the flask out. Alright, finally for today, I'm going to slide the filter paper with the product out of my Buchner and hopefully get the whole filter paper to just behave itself. And slide out. Now I'm going to let it dry and I'll have to come back. I'm not going to film getting a mass on it, but I will let you know what the resulting mass is. We're going to divide that by 2 for an average yield for the class.